Greetings. Welcome to our 26th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus on our February 4th, 2021 webinar titled Geomembrane Attachment and Penetration Design and Installation. I'd like to reintroduce our speaker who's going to cover this podcast on pipe boots. And that's Brendan Simbeck. He is project manager of Simbeck and Associates in Monument, Colorado. Brendan has been installing geosynthetics since 1998 and has installed over 52 million square feet of geomembrane across the United States. We received over 45 questions during and after this webinar, so we broke them up into 3 podcasts so you can quickly find your question and a response. Pat Elliott recorded the first podcast on embedment strips and mechanical attachment, and he answers those questions. Duff Simbeck recorded the second podcast, and he addresses the questions on anchor trenches. And in this podcast, Brendan Simbeck is going to address the many questions we've received on pipe boots. So Brendan, thank you so much for joining us again.
Thank you, Dr. Stark. Glad to be here.
Great. So here we go. First question, ever consider a bellows in pipe boot design?
You know, I can't say that I've seen these successfully used before. If I'm imagining correctly what the bellows is referring to. I'd love to talk more about it if anyone has successful experience with these and would like to contact me. Please feel free to reach out.
Great, Brendan. And what I think the user is asking is about leaving some extra material sort of stacked up, maybe at the top of the slope or around the boot. And if there's movement, that it pulls that bellow or the extra material out. And so I suspect that will be geomembrane specific, whether that is viable or not. What do you think?
Yeah, I'd agree with that. I'd call that a compensation wrinkle. An intentionally placed amount of material for expansion or movement. Of course, when you start doing that, then you always have risks of, foldovers and, creases that can develop. So there is a little bit of risk there, but it is certainly something that needs to be monitored by the installer if that risk is, if there is risk of a little bit of movement there.
Great. Next question is, how does the 90-degree pipe boot account for settlement in a landfill? The pipe may be for a landfill gas extraction system.
Well, pipe boots for gas extraction on the landfill cap are not quite as critical to seal as in locations that will have hydraulic head or be submerged underwater. Landfill cap pipe boots really only need to shed rainwater. And the banding then can be left looser, so it will actually slide before a material failure occurs. In the past, we've extended the tubes for the pipe boot up beyond the cover soil, so they'd be accessible, and it just becomes a maintenance item for the landfill operators as settlement occurs. They can make adjustments or reband as the pipe boot moves. Other designs that I've heard of do not actually band the pipe boot tube to the pipe. Instead, they have an overlapping outer sheath or tube that is fastened above to the pipe. And what this does is it creates a slip joint, which allows the pipe boot tube to telescope or move independently of the outer layer, which sheds away any water.
Great. Next question. I didn't notice any supports under the projecting pipes. At what length or diameter is a support for the cantilever pipe that's sticking out necessary?
Well, I would say that depends on the pipe material, the size, joint type, and location relative to the embankment. We normally see anywhere from 5-foot to 20-foot spacing on pipe supports, but I'd certainly suggest consulting with an expert. I will mention, though, if the support or support pad does rest on the geomembrane, be sure to incorporate some sort of a rub pad between the two.
Yep. Next question. For multiple pipe penetrations, what is the minimum distance that should be provided between the pipes?
Oh, that's a good question. There were some photos of some pipe banks in our webinar that we did that are very challenging to install pipe boots on. I would say, anything less than 12-inch spacing is tight. An 18-inch minimum would be a good standard. But anything greater than 18 inches just makes it that much easier to get everything installed.
Sure. Next question. When are you utilizing HDPE pipe? What is your opinion of extruding the sleeve to the pipe rather than banding it?
Well, my personal opinion is that it is rarely better to do so. For a number of reasons. One, access to the underside of the slope boot is usually not enough for most extrusion welders to maintain proper weld angles. Also, the difference in material thickness from a thick wall pipe to thin geomembrane makes for different welding parameters. There's also different resin compositions from the extrusion rod to the pipe. And that can cause weld failure or cracking. Also there's really no readily available method to test the weld strength when you're doing this. But if the conditions are appropriate for welding, then you could also do both. You just have to move your butyl and your banding back away from the weld.
Yep. How should you refer to the hybrid of prefabricated boot and field fabricated boot?
Well, we call them open tube or split tube boots. I'm sure somebody else could come up with a better name for them, but that's what we call them. I will say, though, that prefabricated boots should be used as much as possible.
Okay. When field fabricating a typical non-mechanical boot, what is the recommended order to weld the different pieces together? For example, the skirt, sleeve, throat, etc.
Well, that's kind of a tough one to give a blanket answer to because it will vary quite a bit. But a general order of operations for most flexible membrane liner pipe boots built in place would be the embankment side of the tube weld, the throat and part way up the sides. Then you'd rotate the boot throat down and finish the tube to skirt weld from both sides towards the apex of the pipe. Then you can slide the boot into place, attach the skirt to the primary liner. You can install your butyl tape and then finish the remainder of the tube weld.
Okay. For polyethylene materials, can you extrude to a pipe in lieu of using band clamps? What would you recommend when the pipe is small, say 1 to 2 inches in diameter?
Well, 1 to 2 inch diameter pipes can sometimes be more challenging than larger pipes, 8 or 10 inch pipe boots. And yes, polyethylene tubes can be welded to polyethylene piping, but I still lean towards a traditional banding.
Okay. For a pipe boot with a steel clamp, how well would the clamp and band hold up to municipal solid waste leachate? Would it eventually rust away?
Well, a steel clamp certainly would rust away, but stainless steel clamps are almost always used, with 304 probably being the most common, but there's also 316 and 400 and other alloys that are available if you need that increased corrosion resistance. We've also in the past welded a geomembrane sleeve over top of the banding in leachate collection sumps, or there's also some corrosion resistant wraps available that could also be incorporated to add a little bit of protection.
Great. Can you discuss non-destructive testing of pipe boots by spark testing with an embedded copper wire?
You know, I wish we had more time to go over this in the webinar, especially since the development of this test method. It has greatly improved the quality of pipe boots installed over the years. For some materials, it really is the only standard test method that can be used to test the tube to skirt weld, regardless of the slope angle or shape of the pipe boot. Maybe FGI can cover this method in one of their instructional videos that we can put on the website.
Great, that's a good idea. Next question, have you ever installed boots over corrugated pipe?
Yes, we have. However, it's really not recommended for most applications because of the extra time and work involved, and really minimal confidence that the seal will hold up when stressed or submerged. Spiral corrugated pipes are the worst, but corrugated pipes with independent grooves are a little bit better. And what we've found with this type of pipe is the best method is to use a corrugated pipe adapter. These rubber adapter rings are sized to the specific diameter of the pipe, and they fill the root between the ridges of the pipe, which provides a greater surface for banding. And these, of course, can be used in conjunction with butyl strips and stainless steel strapping, depending on the application.
Great. Next, how would you suggest constructing a pipe penetration through the slope at the sump, the low point, of a landfill cell? How close can you get to the bottom of the cell before it really becomes a constructability issue?
Well, the first choice would be not to do it. Many landfills we see use a riser pipe that runs upslope from the sump area on top of the geomembrane, so it doesn't have to penetrate the geomembrane. As a rule, you always want to minimize seaming and detail work through sump areas, especially in landfill leachate collection. That being said, if it has to be done, I would suggest the pipe be stubbed out of the embankment with no T's or flanges. The pipe boot can be fabricated and the tube to skirt weld tested, and then retested for extra confidence, and then you install it on the pipe with the bottom edge of the skirt left long enough to extend past the stubbed out pipe. And by doing this, it allows unobstructed access to the seam all around for welding and testing of the skirt to the primary weld. When you do this, you can get a pipe as close as an inch to just resting on the geomembrane, of course with a rub pad if you need it in there, but you can really get it right on the bottom of that sump.
Oh, great. Okay. What is water balance testing for these systems?
Well, I believe I referenced this in the webinar. I referenced a crude non-standard version of water balance testing of pipe boots, which is as simple as inverting the skirt perimeter of a pipe boot, just enough to fill it with water and submerge the tube to skirt weld. That way you can observe any transfer through the weld areas. A true water balance test is a test of the entire liner system after completion by filling with fluid and taking regular level readings over weeks or months and checking them against a control basin to adjust for environmental conditions like precipitation or evaporation.
Right. Slide 13 that you showed, can you discuss this slide again, and in particular, why is the gasket on the outside of the liner material? I've typically seen the gasket on the inside where the tape is located in your example, if you remember that slide, hopefully.
I do, and I think the use of the term gasket may be misleading when referring to the neoprene or the EPDM that's placed beneath the strapping. In the cutaway photo of the basic banding components shown in the webinar, it is the butyl that provides the secondary watertight seal. And I say secondary because it only sees fluid if the caulking that seals the end of the tube fails. So in this configuration that was shown in that photo, the purpose of the EPDM or neoprene is twofold. First, it provides protection from damage to the geomembrane by the strapping and the clip. And second, it provides additional spring or compression if some of the butyl becomes displaced or squeezes out over time. I've seen and heard of similar gasket placements between the geomembrane and the pipe OD. However, in our opinion, it would not provide a better seal than the butyl tape does, as shown in that picture.
Okay. What is an air lance test?
Well, that's a longer answer. I know that FGI has produced a great video explaining the ASTM D4437 air lance test method. I would certainly encourage you to check that out on the FGI website, and it gives a great explanation of that test.
Thanks, Brendan. And for the listeners, that's under the field testing. So there's a section of lab test videos of running laboratory tests on geosynthetics. And so the air lance test is under the field part with the vacuum box test. Okay, next question. Is lined attachment to a slope pipe head wall prior to a pipe boot required or strongly recommended?
Well, I would say that it's strongly recommended. Incorporating this feature greatly reduces the potential for leaks or failures in the boot areas, which do account for a high percentage of leaks in geomembrane systems.
Okay. Are there any considerations around cracking and contracting of the concrete pad during its curing period, especially at the pipe penetration periphery?
Well, yeah, certainly. There's always a good chance concrete will crack and a leak path will develop. As Pat Elliott said, there are two kinds of concrete: cracked and going to crack. This is another instance where a pipe boot on top of the anchor or support pad is a more reliable configuration.
Okay. Next question deals with bootless pipe details. They say it works great for HDPE. Any comments about bootless pipe details?
Well, if I remember correctly, there was a detail that used a mechanical attachment in lieu of a pipe boot. If that's what they're referring to, then yes, it can work well, but relying on the water tightness of concrete over time does present some concern to me.
Yep. Considering an HDPE pipe and an HDPE geomembrane, is it possible / recommended to weld the boot and the pipe at the pipe side instead of using a clamp? Clamping and welding would increase leakage tightness, or is this just increasing work / cost?
Well, it is possible to do both. If you move your banding and butyl back, we don't do this as a standard practice for the reasons I discussed earlier. But yes, it can be done. I just don't see much of a benefit in most situations that would outweigh the risk of doing this over a traditional caulking method.
Right. What type of boot penetration do you recommend for double composite liner systems?
Well, for double line systems, a longer length of pipe is really helpful. With the secondary pipe boot tube banded short with a protective cover or sleeve over the banding to protect the inside of the primary tube or sleeve, which is banded 6 to 8 inches further out. Now, another way to approach this would be to go with the concrete collar method of attachment. So you attach your secondary liner to the concrete pad, and then you only have one pipe boot for your primary layer that is banded. And by using a water stop between the pipe and the concrete, that completes your secondary liner seal.
Okay. Brendan, only 3 questions left, so hang in there. One of the slides had a picture showing a vertical pipe penetration near the top of a dike close to the edge of the liner. A presenter mentioned that this vertical pipe should have been moved outside the liner if possible due to increased risk of failure that the penetration presents. Could you go into a bit more depth of why this type of penetration should be avoided? Does this type of penetration present less of a risk if the penetration is above the fill line area?
Well, yeah, you know what? A leak above water line is much better than a leak below water line.
Yeah.
But best yet is no leak at all.
Yeah.
This picture was really to represent the idea of reduce the penetrations, reduce the risk. If there is no need for a feature to penetrate the liner and adequate space exists for that feature to be located outside the line footprint of the cell, then, you know, why not design it for less work, cost, and risk?
Right. Okay. Next one, and we would also like to learn more about the strap clamps versus the traditional bolt clamp for large diameter pipe, say 600 millimeters to 1.5 meters outside diameter.
Well, those are certainly larger diameter pipes. And with larger diameter pipes, they can require heavier duty strapping or multiple straps, particularly if it's a large HDPE pipe that's exposed and will be subject to expansion and contraction. It can grow enough to pop the banding loose when it's only a 1/2 inch or 5/8 inch wide strap. So I would suggest looking at stronger options when the pipe diameters get that large.
Right. Okay, Brendan, last question. You mentioned the use of a polyurethane sealant at the membrane pipe connection and quoted a specific Sika product. Membranes can be HDPE, LDPE, FPP, which is flexible polypropylene, hypalon, and pipes can be stainless steel, stainless steel, epoxy coated, mild steel, or galvanized mild steel. Are there preferred sealants for the these different combinations of pipes and geomembranes?
Well, that Sikaflex 1A, that's a great product. There's also a couple others out there that perform really well, and they really are compatible with most all geomembranes and pipe materials. And that's something that we can put specifications or data sheets for those sealants on the FGI website as well.
That would be great, Brendan. Okay, Brendan, that's the end of 23 questions on pipe boots. Thank you to all the listeners who submitted those pipe boot questions. And Brendan, thanks so much for taking your time to answer all 23. If you have additional questions or would like additional information on pipe boots, please contact Brendan Simbeck using the information at the end of the webinar slides, or you can email me at fabricatedgeomembrane@gmail.com, and I will forward the message to Brendan, or visit the FGI website at fabricatedgeomembrane.com. Brendan, thanks so much for your time and effort answering those 23 pipe boot questions.
Of course. Thank you for having me.